Good evening, dear listeners. As the day gently fades into night and the world outside grows quieter, I invite you to settle in, find your comfortable position, and prepare for a soothing journey through time. This video is designed to cradle you into a state of relaxation, guiding you softly into the realm of slumber. Here, we will explore a topic that, while perhaps seeming mundane at first glance, is imbued with fascinating intricacies and stories waiting to be unveiled: the tedious history of Roman aqueduct maintenance scheduling and inspection protocols. As we drift through the annals of history, we will uncover the meticulous efforts of the Roman Empire to ensure the smooth functioning of their aqueducts, which were vital lifelines for their cities. Each aqueduct tells a story of engineering brilliance, but it's the quiet diligence of those who maintain them that often goes unnoticed. Throughout our exploration, we will touch upon the daily routines and the dedication of the workers who engaged in this essential task, ensuring that fresh water flowed seamlessly to the bustling streets of Rome. You may find it fascinating to learn how the Romans developed intricate schedules for maintenance, a reflection of their advanced understanding of infrastructure management. We will delve into the protocols they established for inspections, examining how these practices not only preserved the aqueducts but also safeguarded the health and well-being of the citizens who relied on them. As we navigate this journey, imagine the gentle sounds of water flowing through ancient stone channels, the soft whispers of workers discussing their tasks, and the serene environment of a Rome that thrived on the lifeblood of its aqueducts. Along the way, we will explore the various materials used in aqueduct construction, the innovations that arose from necessity, and the challenges that came with maintaining such an elaborate system. We'll also reflect on how the Romans approached the art of planning and scheduling, creating a legacy of efficiency that is still admired today. As your body relaxes and your mind begins to unwind, allow yourself to be enveloped in the tranquility of these stories, where each detail serves not only to inform but also to lull you into a peaceful state. This is not merely a recounting of history, but a gentle embrace of knowledge that invites you to drift deeper into relaxation. In our exploration, you will discover that even the most seemingly tedious subjects can hold beauty and significance. The Romans' commitment to their aqueducts mirrors the diligence we sometimes need in our own lives, reminding us that even the routine can be a source of comfort and stability. Let us take a moment to appreciate this dedication as we journey through time, allowing ourselves to be swept away in the calm of the past. So, dear listeners, as we prepare to embark on this soothing voyage into the world of Roman aqueducts, let your thoughts float freely, like leaves on a gentle stream. Breathe deeply, feel the weight of the day lift from your shoulders, and allow the serene sounds of history to guide you to a peaceful place of rest. Now, let us transition into our main content, where we will begin our exploration into the fascinating and often overlooked world of Roman aqueduct maintenance scheduling and inspection protocols. Relax, and let your mind wander to the heart of ancient Rome, as we uncover the secrets held within its aqueducts. The history of Roman aqueduct maintenance scheduling and inspection protocols is a chronologically expansive and meticulously documented subject, characterized by various administrative practices and architectural considerations that evolved throughout the Roman Republic and Empire. The earliest records pertaining to aqueduct construction date back to the 4th century BCE, particularly with the Aqua Appia, which was constructed in 312 BCE under the aegis of the Roman censor Appius Claudius Caecus. This aqueduct extended approximately 16.4 kilometers, primarily underground, and set a precedent for future aqueducts in terms of engineering and maintenance. The administrative oversight of aqueducts was primarily the responsibility of the aediles, a public office established to supervise urban infrastructure, including the maintenance of roads, public buildings, and aqueducts. The aediles were tasked with ensuring that the water supply remained untainted and that the aqueducts functioned efficiently. The protocols for maintenance and inspection were not standardized until the later years of the Republic, circa 100 BCE, when the growing complexity of Rome's water system necessitated a more structured approach. As aqueducts proliferated, such as the Aqua Marcia, 144 BCE, renowned for its longevity and superior water quality, the need for a systematic inspection regime became apparent. Historical records indicate that routine inspections were conducted at regular intervals, typically every 6 months, although this frequency fluctuated based on seasonal weather patterns and the specific conditions of each aqueduct. Inspectors, known as aquarii, were appointed to conduct these inspections, which entailed examining the structural integrity of the aqueduct, assessing the quality of the water, and identifying any potential blockages or deterioration. Architectural details of aqueducts, such as the use of arches and siphons, played a significant role in the maintenance protocols. The design of the Aqua Claudia, 38 to 52 CE, for example, featured a series of monumental arches that required careful monitoring to prevent structural failure. The protocols for inspection included detailed assessments of the arches, where inspectors recorded the presence of any fissures or signs of wear. The aquarii would employ rudimentary tools, such as plumb lines and measuring rods, to evaluate the alignment and stability of the arches. In addition to visual inspections, the aquarii were responsible for sampling water quality. Procedures mandated that samples be taken at designated intervals, with records meticulously kept in the annals of the aediles' offices. The water quality was assessed based on clarity, odor, and taste, and any discrepancies were noted for further analysis. It was not uncommon for aqueduct inspectors to collaborate with physicians or water quality experts to ensure that the water supplied to the populace met the established standards of purity. The maintenance of aqueducts often required substantial financial resources, compelling the aediles to engage in complex administrative procedures to allocate funds for repairs. The allocation process involved the preparation of detailed budgets, which outlined projected costs for materials, labor, and tools necessary for maintenance operations. Following the inspections, a comprehensive report would be submitted to the Senate, justifying the expenses incurred and outlining any urgent repair needs. Such reports were typically read during Senate sessions, with discussions centering on the implications of maintenance delays on public health and safety. Daily routines for the aquarii were regimented and included a combination of inspections, record-keeping, and coordination with laborers tasked with carrying out repairs. Aquarii were expected to rise early, often before dawn, to inspect various sections of the aqueducts, documenting their findings in ledger books. These records were maintained with great precision, reflecting the importance of accountability in public works. The records would detail the location of the inspection, the date, and any notable findings, including the presence of vegetation that could hamper water flow or signs of erosion at the base of an aqueduct. The maintenance scheduling protocols were further complicated by the seasonal variations that affected the aqueducts. During the dry summer months, the likelihood of blockages increased due to reduced water flow, necessitating more frequent inspections. Conversely, during the rainy season, inspectors would monitor the effects of flooding, which could destabilize the aqueduct structures. As a result, the aquarii adjusted their inspection schedules accordingly, sometimes conducting additional inspections in response to weather forecasts or reports from local citizens regarding unusual water levels or debris accumulation. In the 1st century CE, under the reign of Emperor Augustus, the administration of aqueduct maintenance became more centralized. Augustus established the Cura Aquarum, a governing body specifically tasked with overseeing all aspects of water management within the city of Rome. This body introduced standardized procedures for aqueduct maintenance and inspection, which included the appointment of a chief inspector responsible for coordinating the efforts of the aquarii. This individual was charged with ensuring that inspections adhered to the protocols established by previous administrations, thereby introducing a level of uniformity to the inspection process. The architectural advancements of the time also necessitated updates to maintenance protocols. The Aqua Triana, completed in 109 CE, represented a significant leap in engineering, featuring an extensive network of elevated arches and advanced siphons. The maintenance of such a structure required not only regular inspections but also specialized knowledge regarding the materials and techniques used in its construction. Aquarii tasked with inspecting the Aqua Triana underwent training that emphasized the identification of structural weaknesses and the implementation of preventative measures to avoid costly repairs. Record-keeping became increasingly sophisticated. By the 2nd century CE, detailed logbooks were maintained, documenting each inspection's date, findings, and subsequent actions taken. These logbooks served as historical records and were often referenced by future aquarii during their inspections. A notable figure in this regard was Frontinus, who served as the curator aquarum around 97 CE. In his treatise, De Aqueductu, Frontinus detailed the maintenance practices and inspection protocols of the aqueducts, providing invaluable insight into the administrative processes of his time. He emphasized the importance of routine inspections and the need for ongoing education among aquarii to adapt to evolving engineering challenges. As the Roman Empire expanded, the aqueduct system became more intricate, necessitating the establishment of regional offices to oversee aqueduct maintenance in provinces. Each province would appoint a local curator aquarum, who would implement the central protocols while adapting them to local conditions. These regional curators were responsible for managing local aquarii, ensuring that inspections were conducted regularly, and reporting back to the central administration in Rome. The late Roman Empire witnessed further bureaucratic developments, with an increased emphasis on accountability and transparency in aqueduct maintenance. The introduction of formalized reporting structures allowed for a clearer delineation of responsibilities among various administrative levels. The aquarii were required to submit monthly reports, which included details on inspections, repairs undertaken, and any issues encountered. These reports were reviewed by the local curators, who in turn forwarded them to the higher echelons of administration. This hierarchical structure ensured that all aspects of aqueduct maintenance were scrutinized and addressed in a timely manner. In conclusion, the history of Roman aqueduct maintenance scheduling and inspection protocols encapsulates a complex interplay of engineering ingenuity, administrative oversight, and evolving bureaucratic practices. From the initial constructions in the 4th century BCE through the sophisticated management systems of the late Empire, the protocols established by the Romans laid the groundwork for future water management systems across the world. The meticulous documentation of inspections and maintenance, along with the adaptation of procedures to meet changing needs, highlights the Romans' commitment to providing reliable water supply while ensuring the longevity of their monumental aqueducts. This history is not merely a chronicle of public works but a testament to the organizational acumen and engineering prowess of a civilization that, despite its decline, has left an indelible mark on the infrastructure of modern society. The construction methods employed in the creation of Roman aqueducts were characterized by a systematic approach that utilized both local materials and advanced engineering techniques of the time. The primary materials used in the construction of aqueducts included stone, brick, concrete, and, in some cases, lead for the pipes. The use of concrete, which was developed around 300 BCE, allowed engineers to create more durable structures. The Roman architect Vitruvius, writing in the 1st century BCE, noted the importance of a strong foundation, stating that the foundation must be solid, and the materials must be of the highest quality to ensure longevity. The construction of an aqueduct typically began with a survey of the intended route. Engineers utilized tools such as the chorobates, a leveling instrument, to ensure a slight but consistent gradient, typically around 1:4800, allowing for the gravity flow of water. The construction process was labor-intensive and often involved thousands of workers, including skilled masons, laborers, and overseers. For example, the Aqua Claudia, completed in 52 CE, required approximately 30,000 laborers over its 5-year construction period. In terms of maintenance procedures, the Romans established a series of systematic inspections and repairs to ensure the continuous operation of their aqueducts. Regular inspections were mandated to assess the integrity of the structure and the quality of the water supply. These inspections were typically carried out by appointed officials known as curators aquarum, who were responsible for the oversight of water distribution in the city. The curators were required to submit detailed reports on the condition of the aqueducts, which included notes on any obstructions, leaks, or structural damage. Maintenance protocols involved the clearing of debris from the channels, the repair of any cracks or leaks, and the regular cleaning of settling basins. The Romans utilized a variety of tools for maintenance, including chisels for stonework and rudimentary pumps for clearing water. It is documented that the Aqua Marcia, completed in 144 BCE, underwent annual inspections, with records indicating that repairs were made to sections of the aqueduct approximately every 5 years, particularly in areas prone to erosion. Financial records pertaining to aqueduct maintenance reveal a complex system of budgeting and expenditure. The costs associated with the construction and upkeep of aqueducts were typically allocated from the public treasury. For instance, the total expenditure for the Aqua Appia, the first Roman aqueduct built in 312 BCE, was reported to be approximately 1 million sesterces. This figure included costs for labor, materials, and the purchase of land for the aqueduct's route. Subsequent aqueducts had varying costs depending on their length, complexity, and the materials used. The Aqua Claudia, for instance, had an estimated cost of around 2,500,000 sesterces, a significant investment reflecting its importance in supplying water to Rome. Financial records also noted the costs associated with routine maintenance, which could range from 10,000 to 50,000 sesterces annually, depending on the condition of the aqueduct and the extent of repairs needed. Personnel involved in the maintenance and operation of aqueducts included a variety of roles. The curators aquarum, as mentioned earlier, played a crucial role in overseeing the aqueducts. Below them were various subordinate officials, including inspectors, who were responsible for conducting the actual inspections and reporting their findings. In addition to these roles, skilled laborers known as fabrici were employed for construction and repair tasks. The fabrici were typically trained in masonry, plumbing, and engineering, ensuring that repairs were performed to a high standard. Job descriptions for these roles were detailed and specific. Curators aquarum were expected to possess knowledge of hydraulics, engineering, and public administration, as they were responsible not only for the aqueducts but also for the associated public fountains and baths. Inspectors, on the other hand, were tasked with physically inspecting the aqueducts, documenting their findings, and recommending repairs. The fabrici, as skilled laborers, were hired on a contractual basis, which could last from one season to several years, depending on the scale of the project or the extent of the repairs required. Technical specifications for Roman aqueducts varied widely based on their purpose and the terrain they traversed. The average width of the aqueduct channel was approximately 0.5 meters, while the depth could range from 0.3 to 1 meter, depending on the volume of water required. The gradient was carefully calculated to maintain a flow rate of about 1.5 meters per second, which was deemed optimal for preventing stagnation while ensuring adequate pressure. Aqueducts were often designed with a series of arches and bridges to traverse valleys and uneven terrain. The Pont du Gard, located in southern France and completed around aqueducts, was characterized by its 3 tiers of arches, standing at a height of 48.8 meters. This structure not only served a functional purpose but also showcased the architectural ingenuity of the Romans. The use of a keystone in the arches allowed for greater stability and reduced the amount of material required. In addition to these structural elements, aqueducts also included a series of settling basins and reservoirs, where water could be stored and sediment could settle out. These basins were typically lined with waterproof materials such as concrete or stone to prevent leakage. The dimensions of these basins varied but generally measured approximately 20 meters in length and 10 meters in width, with a depth of about 2 meters. The Romans also implemented a system of overflow channels and sluices to manage excess water, particularly during heavy rainfall. These mechanisms were crucial in preventing flooding and ensuring that the aqueducts remained operational year-round. The design of these channels was meticulous, with a typical width of 0.5 meters and a depth of 0.3 meters, allowing for the effective diversion of excess water. The intricate planning and execution of aqueduct maintenance scheduling and inspection protocols ensured that the Roman aqueducts remained functional for centuries. The combination of advanced engineering techniques, meticulous record-keeping, and dedicated personnel contributed to the longevity of these structures. While much of the Roman Empire eventually declined, the fundamental principles of aqueduct maintenance and management persisted, influencing future generations and laying the groundwork for modern water infrastructure. In conclusion, the history of Roman aqueduct maintenance scheduling and inspection protocols, though tedious, reflects a remarkable achievement in public works and engineering. The methods, materials, personnel, and technical specifications employed in the construction and upkeep of these aqueducts showcase the Romans' dedication to infrastructure and their understanding of hydraulics. The financial records and costs associated with these endeavors highlight the significant investment made by the state in ensuring a reliable water supply for its citizens. Ultimately, the legacy of Roman aqueducts endures, serving as a testament to the organizational acumen and engineering prowess of a civilization that has shaped the infrastructure of modern society. The construction methods and materials employed in the development of Roman aqueducts were critical to their long-term functionality and efficiency. The Romans utilized a variety of techniques and resources, which were meticulously documented in various engineering treatises of the period. The most common materials included stone, brick, and concrete, with specific proportions and mixtures adapted to local environmental conditions and the intended capacity of the aqueduct. The construction of an aqueduct typically began with the selection of a water source, which was often several kilometers away from the intended destination. The Romans employed a surveying technique known as the chorobates, a leveling instrument that ensured the aqueduct maintained a consistent gradient of 1:480, allowing gravity to facilitate the flow of water. The gradient was crucial, as it dictated the speed of water flow and, consequently, the structural integrity of the aqueduct. For example, an aqueduct constructed in 38 BCE in the region of Campania exhibited a gradient of 1:500 for its initial 10 kilometers before transitioning to a 1:350 gradient as it approached its terminus in the city of Pompeii. The Romans also pioneered the use of pozzolana, a volcanic ash that, when mixed with lime and water, created a hydraulic cement capable of setting underwater. This material was particularly advantageous in the construction of aqueducts that traversed valleys or were submerged in water. The Aqua Claudia, completed in 52 CE, utilized pozzolana in its construction, resulting in a durable structure that has largely withstood the test of time, with sections still visible today. Maintenance procedures for Roman aqueducts were as systematic and rigorous as their construction. Scheduled inspections were mandated to assess structural integrity, water quality, and sediment buildup. According to the Lex de Aqueductu, an edict from Emperor Augustus, inspections were to occur quarterly, with a comprehensive review conducted annually. Inspectors were required to document their findings in maintenance logs, detailing any repairs or alterations made. Cleaning the aqueducts was a significant aspect of maintenance. This was typically performed using a combination of manual labor and simple tools, such as wooden scoops and brushes made from animal hair. The process involved removing debris, sediment, and any biological growth that could impede water flow. For instance, the Aqua Marcia, constructed between 144 and 140 BCE, required extensive maintenance due to its length of 91 kilometers, with records indicating that it was cleaned every 5 years, a task that could take upwards of 6 months to complete. Financial records pertaining to the construction and maintenance of aqueducts reveal a meticulous accounting system. The financial administration of aqueduct projects was overseen by a designated officer known as the Curator Aquarum, who was responsible for budgeting and allocating funds. In 33 BCE, the total cost of constructing the Aqua Appia was recorded at 3 million sesterces, a substantial expenditure that underscored the importance placed on water infrastructure. Annual maintenance budgets were also established, with detailed line items for labor, materials, and any additional repairs required. The financial records from the late Republic and early Empire indicate an average annual maintenance cost of approximately 1% of the initial construction cost. This practice ensured that aqueducts remained in good working order and that any potential issues could be addressed before they escalated into larger, more costly repairs. For example, in 10 CE, the repairs to the Aqua Claudia were documented at a cost of 250,000 sesterces, which was a significant investment but necessary to maintain the structural integrity of the aqueduct. Personnel involved in the maintenance of aqueducts were organized into distinct roles, each with specific job descriptions. The Curator Aquarum, as previously mentioned, held overall responsibility for the aqueduct's functionality. Below this position were the aediles, who supervised local public works, including the aqueducts. Each aedile was typically responsible for the maintenance of several aqueducts within their jurisdiction, often collaborating with local laborers. Laborers, referred to as operarii, were the backbone of the maintenance crews. These workers were often recruited from the local population and were skilled in various trades, including masonry, carpentry, and plumbing. On average, a maintenance crew would consist of approximately 50 operarii for large-scale cleaning projects, with shifts organized to ensure continual progress. The daily wage for operarii fluctuated based on the region and economic conditions, averaging between 1 and 3 sesterces per day. In addition to manual laborers, specialized craftsmen were also employed for specific tasks. For example, aqueducts that included arcades or bridges required the expertise of architects and engineers skilled in the design and construction of these structures. The role of the architect was critical, particularly in ensuring that the aqueduct could withstand environmental stresses, such as floods or earthquakes. Technical specifications of Roman aqueducts varied significantly based on their intended purpose and geographic location. The most notable aqueducts, such as the Aqua Appia, Aqua Aniovitis, and Aqua Marcia, were constructed with specific dimensions designed to accommodate the volume of water required by the urban centers they served. The Aqua Marcia boasted a diameter of 1.2 meters for its underground sections, while the surface sections featured an arcade that stood approximately 30 meters high at its tallest point. The water flow capacity of these aqueducts was meticulously calculated. For example, the Aqua Claudia had an estimated capacity of 186,000 cubic meters per day, providing a significant water supply to the city of Rome. Such calculations were critical to ensuring that the aqueducts could meet the demands of a growing population, which, by the 1st century CE, had reached over 1 million inhabitants. The aqueducts were also equipped with various features to facilitate flow regulation and maintenance. Settling tanks, or lacus, were strategically placed at intervals along the length of the aqueduct to allow sediment to settle before the water continued its journey. These tanks were typically rectangular, with an average length of 15 meters and a width of 5 meters, accommodating the flow of water while minimizing sediment buildup. In summary, the construction methods and materials, maintenance procedures, financial records and costs, personnel and job descriptions, and technical specifications of Roman aqueducts provide a comprehensive overview of the complexities involved in their operation. The Romans' meticulous attention to detail and systematic approach ensured that these monumental structures not only served their immediate purpose but also laid the groundwork for future generations to build upon. The enduring legacy of Roman aqueducts is a testament to the civilization's engineering prowess and organizational acumen, which continues to influence modern infrastructure development. The construction methods and materials employed in the building of Roman aqueducts were meticulously documented, reflecting both the engineering standards of the time and the logistical challenges encountered. The Romans primarily utilized a combination of stone, brick, and concrete, with a particular emphasis on pozzolana, a volcanic ash that, when mixed with lime, yielded a durable and water-resistant concrete. This material was particularly favored for its strength and longevity, allowing aqueducts to withstand the test of time. The construction process typically began with meticulous surveying to determine the most efficient route for the aqueduct. This involved the use of tools such as the chorobates, a leveling instrument, which ensured the gradient of the aqueduct was precisely maintained. The ideal gradient ranged from 1:4800 to 1:2400, allowing for a gentle flow of water over long distances without the risk of stagnation or erosion. Roman engineers often employed a system of gravity to transport water, which necessitated a thorough understanding of topography and hydrology. Workers, referred to as aquarii, were often organized into teams, each responsible for specific segments of the aqueduct. The largest aqueducts, such as the Aqua Marcia, constructed between 144 and 140 BCE, stretched over 91 kilometers and required thousands of laborers over several years. The construction of the Aqua Marcia alone is estimated to have consumed approximately 500,000 cubic meters of concrete and stone, necessitating significant resources and logistical planning. Maintenance of aqueducts was an ongoing responsibility, integral to their successful operation. Regular inspections were mandated by the Roman state to ensure the integrity of the structure and the quality of the water supplied. Maintenance procedures included the removal of debris and sediment from the channels, as well as repairs to any sections that had suffered damage due to erosion or structural failure. Inspections were typically conducted quarterly, with a detailed report submitted to local magistrates. These reports documented the condition of the aqueduct, any repairs made, and the overall effectiveness of the water supply, thereby facilitating a systematic approach to maintenance. Financial records associated with aqueduct maintenance reveal a structured budgeting system. Each aqueduct was assigned a specific budget, which was meticulously tracked by local officials known as curators aquarum. For instance, in 33 CE, the budget for the Aqua Claudia was recorded at 600 denarii for maintenance and repairs, reflecting the costs associated with labor, materials, and tools. This financial oversight was critical, as it ensured that aqueducts were well maintained and could continue to serve the populace of Rome and its surrounding regions. Personnel involved in aqueduct maintenance were categorized into various roles, each with distinct job descriptions. The curators aquarum, or water commissioners, were responsible for the overall management of the aqueduct system. They oversaw inspections, maintenance work, and the financial records associated with water supply. Under their supervision were the apophis, or workers skilled in masonry and hydraulics, who executed the physical repairs and upgrades necessary to keep the aqueducts operational. In addition to these roles, a cadre of laborers was frequently employed for manual tasks such as clearing debris, excavating channels, and transporting materials. These laborers were often drawn from the local populace and could be paid in various forms, including denarii or food rations, depending on the availability of resources. Technical specifications of Roman aqueducts varied widely based on geographic and logistical considerations. The arches, one of the most iconic features of Roman aqueducts, were designed using the Roman arch principle, which allowed for the efficient distribution of weight. Typically, the height of arches varied between 6 to 12 meters, although some structures, like the Pont du Gard in France, reached heights of 49 meters. The span of these arches could extend up to 25 meters, demonstrating the innovative engineering capabilities of Roman builders. The channels themselves were often constructed with a slight gradient and lined with cement to prevent water loss through seepage. The width of these channels ranged from 0.5 meters to 1.5 meters, depending on the volume of water required. The total capacity of an aqueduct could be quantified. For example, the Aqua Appia, completed in 312 BCE, had the capacity to deliver approximately 75,000 cubic meters of water daily. As aqueducts aged, the necessity for rehabilitation became paramount. Major repairs were often scheduled every 10 to 15 years, with larger undertakings requiring the temporary diversion of water supply to allow for safe work conditions. The use of lead pipes, known as fistulae, was common for water distribution, and these too required regular inspection due to the potential for corrosion and leakage. The replacement of lead pipes was documented in financial records, with costs for new materials averaging around 150 denarii per installation. The bureaucratic oversight of aqueducts extended beyond mere construction and maintenance. It also included legal ramifications. Laws governing water rights and usage were codified, ensuring equitable distribution among the populace. The Lex Quinctia, enacted in 33 BCE, established guidelines for the allocation of water and penalties for unauthorized diversion, emphasizing the importance of regulated water management. In summary, The history of Roman aqueduct maintenance scheduling and inspection protocols reveals a sophisticated system of construction, maintenance, and bureaucratic oversight, reflective of the broader organizational capabilities of Roman society. Through the effective use of materials, labor, and financial management, the Romans created an extensive network of aqueducts that not only facilitated the growth of cities but also laid the foundational principles for modern civil engineering practices. The meticulous attention to detail in every aspect of aqueduct operation, from the technical specifications of construction to the financial records of maintenance, underscores the importance of water management in sustaining the Roman Empire. This extensive and tedious account of Roman aqueduct maintenance remains a critical area of study for historians and engineers alike, as it continues to inform contemporary infrastructure practices. The construction methods and materials employed in the building of Roman aqueducts were meticulously documented, reflecting both the engineering standards of the time and the logistical challenges encountered. The Romans primarily utilized a combination of stone, brick, and concrete, with a particular emphasis on pozzolana, a volcanic ash that, when mixed with lime, yielded a durable and water-resistant concrete. This material was particularly favored for its strength and longevity, allowing aqueducts to withstand the test of time and the pressures of water flow. The use of pozzolana dates back to the early Roman Republic, around the 4th century BCE, when engineers began experimenting with various types of cementitious materials. By the 1st century CE, the Romans had perfected the formula, leading to the construction of some of the most famous aqueducts, such as the Aqua Appia, built in 312 BCE, and the Aqua Claudia, completed in 52 CE. The Aqua Appia, for instance, stretched approximately 16.4 kilometers and relied heavily on underground channels, which posed unique engineering challenges. The construction of these underground sections demanded advanced surveying techniques and precise measurements to ensure a consistent gradient, which was typically set at a fall of about 1 meter for every 480 meters to maintain a steady flow of water. Roman aqueducts showcased a variety of construction techniques adapted to specific geographical and environmental conditions. In regions where the terrain was elevated, the use of arches became vital. The Aqua Marcia, completed in 144 BCE, is a prime example. Its impressive arches soared over valleys, utilizing a sequence of 91 arches that reached heights of up to 30 meters. The arches were meticulously constructed using large blocks of limestone and tuff, a light volcanic rock, which provided both strength and an aesthetically pleasing appearance. In contrast, when traversing mountainous areas or crossing rivers, engineers employed a different approach. The use of siphons, for instance, became crucial in these scenarios. A notable example of this is the Aqua Claudia, which included an intricate siphon system that allowed water to flow over the Anio River. The siphon consisted of a series of tubes that dipped below the riverbed, utilizing gravity to draw water through the system. This innovation not only highlighted Roman ingenuity but also underscored their understanding of hydraulics, as they were able to manipulate water flow across challenging landscapes. The logistical challenges of transporting materials for aqueduct construction cannot be overstated. The Romans developed extensive networks of roads and waterways to facilitate this process. Stone blocks, for example, were often quarried from local sources, but heavier materials had to be transported over long distances. This required careful planning and coordination, often involving the use of sledges and carts to move materials over rough terrain. The construction of the Aqua Claudia involved transporting limestone from quarries located in the surrounding hills, a process that required not only physical labor but also innovative techniques to minimize wear and tear on the materials. Moreover, the construction timeline for these aqueducts was extensive. The Aqua Appia, for instance, took nearly a decade to complete, while the Aqua Claudia was under construction for over 15 years. This lengthy timeframe can be attributed to the sheer scale of the projects, the complexity of the engineering involved, and the need to ensure structural integrity throughout the process. Additionally, the Romans faced natural obstacles, including floods and landslides, which could delay construction and necessitate alterations to the original plans. The historical context of Roman aqueduct construction reflects not only the empire's engineering prowess but also its socio-political ambitions. Water was a vital resource for urban centers, and the ability to supply fresh water to cities such as Rome was a source of pride for the state. The construction of aqueducts was often a means to demonstrate the power and benevolence of the ruling elite. For example, Emperor Trajan commissioned the Aqua Traiana in 109 CE to supply water to the burgeoning population of Rome, which had grown to over 1 million inhabitants by that time. This aqueduct stretched approximately 65 kilometers and included numerous bridges and tunnels, showcasing the engineering capabilities of the Roman Empire at its zenith. Furthermore, Roman aqueducts were not merely functional, they were often accompanied by elaborate public works, such as fountains and baths, which served both practical and social purposes. The integration of aqueducts into the urban landscape transformed cities, making them more livable and fostering a sense of community. The careful planning and execution of these projects illustrated the Romans' commitment to public health and civic pride. In conclusion, the construction of Roman aqueducts was a monumental achievement that combined innovative engineering, effective resource management, and a deep understanding of the physical environment. The meticulous documentation of construction methods, materials, and logistical challenges provides insight into the sophistication of Roman technology and its enduring legacy in the field of civil engineering. Through the lens of aqueduct construction, we gain a deeper appreciation for the Roman Empire's architectural ingenuity and its lasting impact on urban development throughout history. The construction methods and materials utilized in the establishment of Roman aqueducts were a testament to the empire's engineering prowess and its understanding of local geological conditions. Primarily, aqueducts were constructed using locally sourced materials, which varied depending on the region. For instance, in areas abundant with limestone, such as the vicinity of Rome, builders favored limestone blocks measuring approximately 0.5 meters by 1 meter, each weighing around 100 kilograms. These blocks were shaped using chisels and hammers to ensure a snug fit, reducing the need for mortar. In contrast, regions such as Campania, where volcanic tuff was prevalent, utilized this lighter stone for constructing aqueduct arches, as it allowed for a reduction in the overall weight of the structure. The Roman engineers employed a technique known as opus cementitium, a precursor to modern concrete, which was a mixture of lime mortar, water, and aggregates such as volcanic ash. This material was particularly effective in waterproofing the conduits that transported water from sources to urban centers. The first extensive use of opus cementitium can be traced back to the Aqua Appia, completed in 312 BCE, which was the first aqueduct built in Rome. The structure featured a gradient of 1.5 meters per kilometer, allowing water to flow naturally to the city. Maintenance procedures for these monumental constructions were as meticulous as their design. The aqueducts required regular inspections to ensure they remained operational. By the 1st century BCE, the Roman Senate had established a formal system for monitoring the aqueducts, appointing a position known as the Curator Aquarum. This official was responsible for the maintenance of the aqueducts, overseeing a team of laborers, and ensuring that any necessary repairs were conducted promptly. The inspections were typically carried out biannually, once in the spring and once in the autumn, to coincide with periods of lower water demand. During inspections, workers were tasked with examining the structural integrity of arches, the condition of the conduits, and the cleanliness of catchment areas. The Romans developed a standardized checklist for these inspections, which included measurements of the water flow, assessments of sediment buildup, and visual inspections for cracks or structural failure. For example, if sediment buildup exceeded 0.3 meters in a conduit, it was deemed necessary to allocate resources for cleaning, which involved the laborious process of removing debris by hand. The financial records and costs associated with the construction and maintenance of aqueducts were meticulously documented by Roman officials. The expenses were categorized into several distinct areas: materials, labor, and administrative costs. An average aqueduct, such as the Aqua Marcia, constructed between 144 and 140 BCE, had an estimated total cost of 1,200,000 sesterces. Historical records indicate that approximately 60% of this budget was allocated to labor costs, with skilled laborers earning between 4 and 6 sesterces per day, while unskilled workers earned a mere 2 sesterces. The procurement of materials also represented a significant portion of the budget. For example, the purchase of limestone blocks could range from 0.5 to 2 sesterces per block, depending on the distance from the quarry. The transport of these materials was often the responsibility of local laborers, who charged fees based on the distance traveled. The Roman government implemented a rigorous accounting system to track expenditures, ensuring that each project remained within budget. Personnel involved in the aqueduct maintenance and construction included a variety of specialized roles. The Curator Aquarum served as the chief overseer, while the Magister Operum was responsible for the day-to-day management of construction and maintenance crews. The workforce was typically composed of skilled laborers, including stonemasons, engineers, and surveyors, alongside unskilled laborers who performed manual tasks such as digging and transporting materials. The technical specifications of Roman aqueducts varied considerably, but certain standards were maintained across most projects. The typical gradient for aqueducts was around 1:480, meaning that for every 480 meters of horizontal distance, the aqueduct would descend by approximately 1 meter. This gradient allowed for a consistent flow of water without causing erosion or silting in the conduits. Furthermore, the diameter of the conduits typically ranged from 0.5 to 1.5 meters, depending on the volume of water required by the urban center it served. The construction of bridges and arches to traverse valleys was another significant technical consideration. The arches were constructed using a series of voussoirs, each precisely cut to fit together without the need for mortar. The most famous of these structures, the Pont du Gard in France, features 3 tiers of arches, the highest reaching a height of 48.8 meters, and was capable of transporting 20,000 cubic meters of water each day to the city of Nîmes. Another important aspect of aqueduct construction was the use of settling tanks, which were strategically placed along the route to allow sediment to settle before the water entered the urban supply. These tanks were typically rectangular, measuring 10 meters by 5 meters, and had a depth of 2 meters. The Romans recognized the importance of maintaining clean water supplies, and the design of these tanks reflected their engineering sophistication. In summary, the construction methods and materials of Roman aqueducts were characterized by the use of locally sourced materials, advanced techniques such as opus cementitium, and a meticulous approach to scheduling maintenance and inspections. The financial oversight of these projects was thorough, with detailed records of expenditures and labor costs. Personnel involved in aqueduct operations were specifically trained for their roles, ensuring that each aspect of construction and maintenance was addressed with precision. The technical specifications adhered to by Roman engineers set a standard that would influence water management systems for centuries to come, reflecting the empire's commitment to infrastructure and public health. The construction methods and materials utilized in the establishment of Roman aqueducts were a testament to the empire's engineering prowess and its understanding of local geological conditions. Primarily, aqueducts were constructed using locally sourced materials, which varied depending on the region. For instance, in areas abundant with limestone, such as the vicinity of Rome, builders favored limestone blocks measuring approximately 0.5 meters by 1 meter, each weighing around 100 kilograms. The use of such durable materials not only ensured the longevity of the structures but also reflected the Romans' ability to adapt to their environment. One notable example of Roman aqueduct engineering is the Aqua Appia, constructed in 312 BCE. This was the first aqueduct built in Rome, running approximately 16.4 kilometers, 10.2 miles, from the springs near the Anio River to the city. The Aqua Appia was primarily underground, utilizing a series of tunnels to navigate the uneven terrain. This innovative approach minimized the risks posed by surface obstacles and allowed for a reliable water supply to the growing population of Rome. The construction involved extensive surveying and excavation, with workers digging trenches and utilizing wooden scaffolding to support their efforts. In contrast, the Aqua Marcia, completed in 144 BCE, is famous for its above-ground arches and bridges, showcasing a different aspect of Roman engineering. Spanning about 91 kilometers, 56.5 miles, it was one of the longest aqueducts constructed during the Republic. The Aqua Marcia was particularly noted for its high-quality water, sourced from springs in the Anio Valley, and its construction involved the use of large arches made from concrete and brick. These arches, standing as high as 30 meters, 98 feet, allowed the aqueduct to maintain a consistent gradient, facilitating the movement of water through gravity alone. This method of construction was not only practical but also aesthetically pleasing, as it created iconic structural landmarks that remain influential in architecture today. The Romans were meticulous in their approach to measuring gradients for aqueduct construction, typically aiming for a slope of about 1:4800 to ensure a steady flow of water. This subtle incline, though minimal, was crucial for maintaining the aqueduct's efficiency over long distances. Engineers employed tools such as the chorobates, a leveling instrument, to accurately gauge the terrain and ensure that the aqueduct maintained its required slope. In some cases, when the terrain proved particularly challenging, the Romans developed innovative solutions like the use of inverted siphons. An example of this can be seen in the Aqua Claudia, completed in 52 CE. This aqueduct traversed valleys and low-lying areas by employing a series of inverted siphons that allowed the water to flow beneath obstacles. The use of clay pipes and lead tubing in these sections demonstrated the Romans' advanced understanding of materials and their properties. The Aqua Claudia not only delivered water to Rome but also served as a testament to Roman resilience in overcoming natural barriers. The Roman aqueducts were not solely functional, they were also monumental in their design and construction. The Pont du Gard in France, built in the 1st century CE, exemplifies this dual purpose. This aqueduct bridge, standing 49 meters, 160 feet, tall with 3 tiers of arches, is a remarkable feat of engineering and artistry. It was part of a 50-kilometer, 31-mile, aqueduct that supplied water to the city of Nîmes. The meticulous construction involved precise stone cutting and placement, with each block fitting together without the need for mortar, showcasing the Romans' skill in masonry and their understanding of structural integrity. Additionally, the aqueducts served as a symbol of Roman authority and civilization. The construction of these grand structures often coincided with periods of political stability and prosperity. For instance, during the reign of Emperor Augustus, 27 BCE, 14 CE, significant investments were made in public works, including aqueducts, to improve the quality of life for citizens and reinforce the empire's infrastructure. The Aqua Traiana, commissioned by Emperor Trajan in the early 2nd century CE, was another monumental project that not only improved water supply but also demonstrated the empire's commitment to urban development and public health. The maintenance of aqueducts was as crucial as their construction. Regular inspections were mandated to ensure that the channels remained clear of debris and blockages. Workers known as aquarii were responsible for the upkeep of these vital water conduits, often utilizing tools like shovels and nets to remove sediment and refuse. This commitment to maintenance ensured that the aqueducts continued to function effectively for centuries, with some remaining in use well into the Middle Ages. In conclusion, the construction of Roman aqueducts is a remarkable testament to the empire's engineering ingenuity and adaptability. The combination of local materials, innovative techniques, and meticulous planning allowed the Romans to create an extensive network of aqueducts that not only served practical needs but also stood as enduring symbols of their civilization. Through examples like the Aqua Appia, Aqua Marcia, Aqua Claudia, and Pont du Gard, we see a legacy of engineering excellence that continues to inspire and inform modern infrastructure projects around the world. The history of Roman aqueduct maintenance scheduling and inspection protocols is a subject that, while seemingly arid, reveals a complex web of regional variations, bureaucratic regulations, and evolving logistics that illuminated the ancient world's understanding of water management. As we delve into this tedious history, we shall explore the nuances of these protocols across different regions, the evolution of practices over various time periods, the bureaucratic frameworks that govern them, and the intricate supply chain and record-keeping methods that ensured the smooth operation of these monumental waterworks. #Regional variations and comparisons. The Roman Empire, known for its remarkable engineering feats, boasted a remarkable variety of aqueducts, each tailored to the specific geographic and climatic conditions of its region. The methods of maintenance and inspection of these aqueducts varied considerably from one province to another, reflecting local practices and the availability of resources. In the arid provinces of North Africa, for instance, aqueducts were often constructed with a greater emphasis on subterranean channels to minimize water loss via evaporation. This necessitated a distinct maintenance protocol that included regular inspections of underground conduits, which were often obscured from view. Inspectors in these regions were frequently tasked with ensuring the integrity of earthenware pipes and checking for the encroachment of sand and silt that could clog water flow. Conversely, in the lush provinces of Gaul, elevated aqueducts were more common, necessitating maintenance protocols that prioritized the inspection of arches and viaducts, as well as the management of vegetation that could threaten the structural integrity of these aerial constructs. The differences in aqueduct maintenance were also influenced by the local governance structures. In Rome itself, the Aqua Appia, the city's first aqueduct, was managed by the curators aquarum, a group specifically designated to oversee water management. Their protocols included a rigorous schedule for inspections, often conducted biannually, to ensure the aqueduct's functionality. By contrast, in newly conquered provinces, the administration of aqueducts was often less formalized. Local magistrates might be appointed to oversee water management, but the lack of established protocols often resulted in ad hoc maintenance schedules that relied heavily on local labor forces, which could be erratic in terms of availability and reliability. #Evolution over different time periods. The evolution of aqueduct maintenance and inspection protocols throughout the Roman Empire mirrored broader societal changes, including shifts in governance, technological advancements, and changing public health priorities. Initially, during the Republic period, maintenance protocols were rudimentary at best, often relying on the labor of local citizens who would report issues as they arose. This informal system, while effective to some degree, was often plagued by inefficiencies and inconsistent oversight. As the empire expanded, particularly during the Julio-Claudian dynasty, a more systematic approach emerged, driven largely by the centralization of power and the establishment of a more structured bureaucracy. The introduction of detailed inspection reports and maintenance schedules became commonplace, with inspectors required to document their findings and recommendations in triplicate, one for local archives, one for provincial governors, and one for the curators in Rome. This period saw the development of standardized protocols, including the implementation of annual inspections that covered not just the aqueducts but also the accompanying infrastructure, such as settling tanks and distribution reservoirs. By the time of the Severan dynasty, the maintenance protocols had become increasingly sophisticated, with specialized teams of laborers trained specifically in aqueduct repairs. The introduction of new materials, such as hydraulic concrete, revolutionized the construction and maintenance of aqueducts, allowing for longer spans and more durable structures. The meticulous record-keeping practices established during this period meant that maintenance histories could be traced over decades, allowing for more informed decision-making regarding repairs and upgrades. #Bureaucratic regulations and laws. The bureaucratic regulations governing aqueduct maintenance were labyrinthine, reflecting Rome's obsession with order and control. Laws concerning water rights and infrastructure were codified in various legal texts, including the 12 Tables and later compilations, which established a clear framework for the responsibilities of both public officials and private citizens. The Lex Fuefia Caninia, for example, laid out specific requirements for the maintenance of public aqueducts and imposed penalties for neglecting their upkeep. The role of the curators aquarum was central to this regulatory framework. These officials were empowered to levy fines against those who impeded the flow of water, whether through the illegal diversion of water for personal use or neglecting their responsibilities in maintaining the aqueducts. They were also charged with ensuring that aqueducts met the standards set forth in municipal codes, which included specifications regarding the materials used in construction and the methods of repair. Furthermore, the bureaucratic apparatus surrounding aqueducts extended to local magistrates, who were responsible for managing the daily operations of water supply in their jurisdictions. This often included the oversight of labor forces dedicated to maintenance tasks, the allocation of resources for repairs, and the management of disputes arising from competing water rights claims. The intricate network of regulations ensured that aqueduct maintenance was a matter of public concern, with citizens encouraged to report any issues or irregularities to their local magistrates. Supply chain and logistics. The supply chain and logistics involved in aqueduct maintenance were as convoluted as the bureaucratic regulations governing them. Maintaining a network of aqueducts required not only a skilled labor force but also a reliable supply of materials and tools necessary for repairs. The logistics of sourcing these materials varied widely depending on the location of the aqueduct and the resources available in the surrounding area. For instance, in the vicinity of Rome, builders could easily access local quarries for limestone and tufa, which were essential for constructing and repairing aqueducts. However, in more remote provinces, materials had to be transported over long distances, often involving complex arrangements with local suppliers and laborers. The transportation of these materials was often hampered by the state of the roads, which could be treacherous and poorly maintained, leading to delays in repair schedules. The logistics of labor management were equally complex. Laborers were typically recruited from local populations, and their availability could fluctuate due to agricultural cycles, seasonal work demands, or military conscription. This necessitated a flexible approach to scheduling maintenance tasks, often requiring inspectors to adapt their plans based on the availability of workers. The reliance on seasonal labor also meant that maintenance schedules had to be carefully coordinated with the agricultural calendar to ensure sufficient manpower during critical repair periods. Record-keeping methods. Record-keeping was a crucial aspect of aqueduct maintenance that ensured accountability and facilitated the smooth operation of these extensive waterworks. The methods employed for record-keeping varied over time and across regions but shared a common goal: to create a reliable history of inspections, repairs, and recommendations. In the early days of aqueduct construction, records were often simple notations made on wax tablets or inscribed on stone. These early records typically included basic information such as the date of inspection, the names of the inspectors, and any observed issues. However, as the bureaucratic structure surrounding aqueduct management became more formalized, the methods of record-keeping evolved. By the time of the late Republic and early Empire, a more sophisticated system of documentation emerged. Inspectors were required to maintain detailed logbooks that chronicled every aspect of an aqueduct's maintenance history, including the frequency of inspections, the nature of repairs conducted, and any recommendations for future work. These logbooks, often kept in triplicate, formed the backbone of the aqueduct management system, allowing for the easy cross-referencing of information and ensuring that no detail was overlooked. Additionally, the use of parchment and papyrus for record-keeping became more prevalent, facilitating the preservation of records over longer periods. The invention of the codex also allowed for more organized compilations of inspection reports and maintenance schedules, making it easier for officials to access the information they needed quickly. In conclusion, the tedious history of Roman aqueduct maintenance scheduling and inspection protocols reveals a fascinating interplay of regional variations, evolving practices, bureaucratic regulations, logistics, and meticulous record-keeping. While the subject may seem mundane on the surface, the depth of detail involved in these aspects underscores the significance of water management in the ancient world. The Romans' commitment to maintaining their aqueducts was not merely a matter of practicality but a reflection of their understanding of the importance of water supply in sustaining their vast empire. As we examine this intricate network of maintenance practices, we gain insight into the complexities of Roman governance, engineering, and societal organization, highlighting an often overlooked aspect of their remarkable civilization. The tedious history of Roman aqueduct maintenance scheduling and inspection protocols, Part 7. Regional variations and comparisons. The Roman Empire, with its vast expanse stretching from the British Isles to the sands of North Africa, presented a mosaic of regional adaptations in the management and maintenance of aqueduct systems. These adaptations were not merely incidental, they evolved from local geographic conditions, climatic variations, and the availability of resources. For instance, in the arid regions of North Africa, where water scarcity was a pressing concern, the maintenance of aqueducts was prioritized differently compared to the more temperate regions of Gaul. In North Africa, aqueducts were often constructed with a focus on minimizing evaporation. The use of subterranean channels was common, wherein water would flow through covered conduits to reduce exposure to the sun. Maintenance schedules in these regions were frequently dictated by the agricultural calendar. Farmers depended heavily on the aqueducts for irrigation, thus necessitating inspections and repairs before the planting season. This led to a more communal approach to maintenance, where local farmers, organized into cooperatives, would collaborate to ensure that the aqueducts remained functional. Conversely, in the wetter climates of the western provinces, such as Britannia and parts of Gallia, the maintenance of aqueducts often revolved around managing excess water flow. Here, the protocols were structured around seasonal flooding, requiring regular inspections during the rainy seasons. The Roman authorities implemented stricter regulations regarding drainage systems to mitigate the effects of flooding, resulting in a complex network of aqueducts and drains that needed constant oversight. In Italy, particularly around the city of Rome, aqueduct maintenance was heavily bureaucratized. The central government mandated detailed inspection protocols, often involving multiple layers of oversight. Inspectors, known as curators aquarum, were appointed to oversee the aqueduct's functionality, and they operated within a framework of strict legal guidelines. The varying regional practices highlighted the need for a tailored approach to aqueduct maintenance, reflecting the unique challenges posed by local environments. Evolution over different time periods. The evolution of aqueduct maintenance protocols can be broadly segmented into three key periods: the Republican era, the height of the Empire, and the decline of Roman authority. Each of these epochs brought about distinct changes in the administration and logistical approaches toward aqueduct maintenance. During the Republican era, the aqueducts were largely the result of private initiatives, often funded by wealthy individuals seeking to gain favor with the populace. Maintenance was sporadic and typically reactive. Repairs were made when there was a notable failure in the system. Documentation from this time illustrates a lack of formalized scheduling. Instead, maintenance was performed at the whim of local landowners or the occasional decree from the Senate. The height of the empire marked a significant shift. With the consolidation of power under Augustus, the aqueduct system became a symbol of Roman engineering prowess and civic pride. During this period, maintenance scheduling transformed into a systematic endeavor, characterized by the establishment of regular inspection cycles. The introduction of the Lex Aelia de Aqueductu in 33 BCE formalized maintenance responsibilities, mandating that aqueducts be inspected biannually. This law represented a critical evolution in bureaucratic oversight and laid the groundwork for future regulations. As the empire began to decline, the focus on aqueduct maintenance waned. Resource allocation shifted toward military concerns, and the infrastructure that once represented the glory of Rome fell into disrepair. Inspection protocols became irregular, and the once detailed records of aqueduct conditions deteriorated into mere anecdotes. The decline in centralized authority meant that local militias or informal community groups assumed responsibility, leading to a fragmented approach to aqueduct management. Bureaucratic regulations and laws. Central to the evolution of aqueduct maintenance in ancient Rome were the numerous bureaucratic regulations and laws governing the construction and upkeep of these vital water systems. The Lex Aquaria, a set of legal statutes, established the foundational framework for aqueduct management. This legislation delineated the responsibilities of various stakeholders, including local magistrates, landowners, and the central government, in the maintenance and operation of aqueducts. One notable regulation was the Accountability Clause, which stipulated that any individual or entity failing to maintain sections of the aqueducts would be subject to penalties. This clause was critical in ensuring that the responsibilities of maintenance were taken seriously, as the consequences of neglect could lead to widespread water shortages, impacting both agriculture and public health. Moreover, the establishment of the curator's aquarum as a formal position within the Roman bureaucracy highlighted the importance of dedicated oversight. These inspectors were charged not only with the physical inspection of aqueducts but also with the maintenance of detailed records regarding the condition of the infrastructure. Their reports would be forwarded to higher authorities, ensuring a centralized repository of information that could inform future maintenance efforts. The bureaucratic framework also included regulations concerning the materials used in aqueduct construction and repair. Specific guidelines mandated that only certain types of stone, mortar, and other materials be utilized, as these were deemed to ensure the longevity and functionality of the aqueduct systems. Such regulations reflect a deep understanding of engineering principles, as the Romans sought to optimize the performance of their waterworks. Supply chain and logistics. The logistical challenges associated with aqueduct maintenance cannot be overstated. The intricate networks of aqueducts stretched across vast distances, often traversing rugged terrain and requiring significant resources for upkeep. The supply chain involved in maintaining these systems was multifaceted, encompassing the procurement of materials, the organization of labor, and the scheduling of maintenance activities. Procurement of materials was often a localized endeavor, with stone quarries and clay pits strategically identified to minimize transport distances. It was not uncommon for local authorities to establish contracts with quarry operators, ensuring a steady supply of materials for repairs. Documentation from the period reveals detailed accounts of material inventories, which were meticulously tracked to prevent shortages that could delay maintenance efforts. Labor organization was another critical aspect of the logistics surrounding aqueduct maintenance. The Roman Empire relied heavily on both free labor and enslaved individuals for construction and repair work. Laborers were typically organized into crews, each assigned to specific sections of the aqueducts. The scheduling of these crews needed to align with the agricultural calendar to minimize disruption to local farming activities. This consideration highlights the Romans' ability to integrate aqueduct maintenance into the broader economic framework of local communities. Transportation of materials to repair sites often involved complex logistics, particularly for remote aqueduct sections. Roman engineers employed various methods, including the use of carts, pack animals, and even human carriers, depending on the terrain. The establishment of temporary supply depots along critical routes ensured that maintenance crews had access to necessary resources without significant delays. Record-keeping methods. The meticulous record-keeping practices of the Romans played a vital role in the effective management of aqueduct maintenance. The Romans utilized a variety of methods to document the condition of aqueducts, maintenance schedules, and inspection results. These records served as essential tools for bureaucrats, engineers, and local magistrates in their efforts to maintain the extensive water systems. One predominant method of record keeping involved the use of tabulae, or wax tablets, which were easily transportable and allowed for quick notations. Inspectors would carry these tablets during their rounds, jotting down observations regarding the condition of the aqueducts and any required repairs. Once back at their offices, these notes would be transcribed onto more permanent materials, such as parchment or papyrus, ensuring the longevity of the records. Another significant aspect of Roman record-keeping was the establishment of public registers. These registers served as central repositories for information regarding aqueduct maintenance and inspections. They were often housed within municipal offices and were accessible to local citizens, providing transparency and accountability in the management of public resources. Citizens were encouraged to report any issues they observed, thereby fostering a collaborative relationship between the government and the populace. The evolution of record-keeping also reflected advancements in Roman literacy and administrative techniques. As the empire expanded, the need for standardized documentation grew, leading to the development of formalized templates for maintenance reports. These templates ensured that inspectors provided consistent and comprehensive information, facilitating better decision-making by authorities. In conclusion, the history of Roman aqueduct maintenance scheduling and inspection protocols is a complex tapestry woven from regional variations, bureaucratic regulations, logistical challenges, and diligent record-keeping practices. Each aspect of this history reveals not only the ingenuity of Roman engineering but also their profound understanding of the importance of water management in sustaining their civilization. As we continue to explore these themes, we uncover a narrative that, while seemingly mundane, is rich with insights into the administrative capabilities of one of history's most influential empires. The tedious history of Roman aqueduct maintenance scheduling and inspection protocols continues with an examination of regional variations and comparisons, the evolution of these practices over different time periods, bureaucratic regulations and laws, the supply chain and logistics involved in aqueduct maintenance, and the record-keeping methods employed by Roman officials. Each of these aspects contributes to a comprehensive understanding of the complexities associated with the maintenance of aqueduct systems in ancient Rome. Regional variations and comparisons. The Roman Empire spanned vast territories, leading to significant regional differences in aqueduct maintenance practices. The aqueducts in the colder northern provinces, such as Britannia, were subject to different environmental challenges compared to those in the sun-drenched southern provinces, like Sicilia. The freezing temperatures of Britain necessitated winter inspections to mitigate frost damage, while aqueducts in warmer climes often contended with sedimentation issues due to seasonal rainfall patterns. In addition to climatic factors, local governance also played a pivotal role in maintenance protocols. In the more urbanized regions, such as Rome itself, the presence of a more developed bureaucratic structure enabled a systematic approach to inspection schedules. The central authority could mandate inspections at regular intervals, often quarterly, and this process was documented meticulously. In contrast, rural provinces lacked the same level of oversight. Local officials were frequently reliant on verbal reports and less formalized inspection schedules, resulting in a more ad hoc approach to aqueduct maintenance. Comparative studies of aqueduct systems in different regions reveal that the degree of urbanization directly influenced the robustness of maintenance protocols. For instance, the elaborate aqueduct system of Rome, which consisted of multiple conduits, such as the Aqua Claudia and Aqua Marcia, was managed by dedicated officials known as the curators aquarum. These curators were responsible for ensuring that the aqueducts were not only functional but also safe for public use. In contrast, smaller towns, such as those in the provinces, often had a single, less capacitated official overseeing a local aqueduct, leading to disparate standards of maintenance and inspection. Evolution over different time periods. The evolution of aqueduct maintenance and inspection practices can be traced through three distinct periods: the Republican era, the early imperial period, and the late imperial period. During the Republican era, the maintenance of aqueducts was largely a communal responsibility. Citizens were expected to contribute labor and resources, which fostered a sense of civic duty. Records from this time show that maintenance schedules were often informal, with inspections conducted based on community consensus rather than a centralized mandate. As the empire transitioned into the early imperial period, the scale of aqueduct construction increased dramatically, necessitating a more formalized structure for maintenance. The emperors recognized the importance of a reliable water supply for urban populations and instituted regulations that required regular inspections and maintenance schedules. The Lex Irnitana, a legal text from the early imperial period, outlined specific duties of water officials, including the need for biannual inspections and the obligation to report issues to higher authorities. By the late imperial period, the pressures of urbanization and population growth led to a more bureaucratic and regulated approach to aqueduct maintenance. This era saw the establishment of standardized inspection protocols, which dictated not only the frequency of inspections but also the qualifications required for inspectors. The Codex Theodosianus, a compilation of laws from the 5th century, included detailed regulations regarding the responsibilities of aqueduct maintenance, emphasizing the need for trained personnel and outlining penalties for negligence. Bureaucratic regulations and laws. Bureaucratic regulations surrounding aqueduct maintenance were extensive, reflecting the Roman penchant for legalism. The governance of aqueduct systems was codified in numerous laws and decrees that delineated the responsibilities of various officials. The roles of the curators aquarum were clearly defined, with stipulations regarding their authority to allocate resources for maintenance and to impose fines for failures in duty. The legal framework also addressed issues such as land use rights, which were essential for the maintenance of aqueducts that traversed private properties. Landowners were often required to grant access to aqueduct workers, and failure to comply could result in legal action. This legalistic approach ensured that maintenance could proceed without significant hindrance, although local disputes occasionally arose, requiring mediation by magistrates. Moreover, the Lex Aquaria, a set of regulations regarding the use of water resources, was critical in establishing the priorities for aqueduct maintenance. It stipulated conditions under which water could be diverted for agricultural or industrial use, which in turn influenced the scheduling of maintenance work. Inspectors had to navigate these regulations carefully to avoid conflicts with local landowners while ensuring the aqueducts remained in optimal condition. Supply chain and logistics. The logistics of maintaining an extensive aqueduct system were intricate and often cumbersome. The supply chain for materials needed for repairs and maintenance was heavily reliant on local resources, which varied significantly across the empire. Aqueduct repairs often required stone, mortar, and lead piping, all of which had to be sourced and transported to the site of maintenance. In regions with abundant natural resources, such as the volcanic tuff of Latium, local officials could procure materials relatively easily. However, in more remote areas, such as the provinces of Gaul, the transportation of materials could be a protracted process, involving lengthy journeys via cart or even by river. This logistical challenge necessitated careful planning and scheduling, as supply delays could significantly impact the maintenance timelines. Moreover, the coordination of labor for aqueduct repairs was another critical aspect of the supply chain. Officials often relied on conscripted labor from local populations, which meant that maintenance schedules had to align with agricultural cycles. During planting and harvest seasons, the availability of labor would dwindle, necessitating the postponement of major repairs. Consequently, records from this period often contain annotations indicating labor availability, which influenced inspection and maintenance scheduling. Record-keeping methods. The meticulous record-keeping methods employed by Roman officials were essential for the effective management of aqueduct maintenance. Documentation was critical not only for ensuring compliance with regulations but also for tracking the history of each aqueduct's maintenance. The Romans utilized a variety of record-keeping methods, including inscribed tablets, papyrus scrolls, and wax tablets, depending on the context and the urgency of the information. The use of wax tablets was particularly popular for day-to-day record keeping, as they allowed for easy editing and reuse. However, for more permanent records, such as those detailing the history of major repairs or inspections, stone inscriptions or papyrus scrolls were preferred. Inspection reports, often compiled by the curators aquarum, contained extensive details about the condition of the aqueducts, any identified issues, and the actions taken to address them. These reports were often categorized by aqueduct and included information on the frequency of inspections, documented repairs, and even the financial expenditures associated with maintenance activities. The preservation of such records allowed for a longitudinal study of each aqueduct's status, facilitating informed decision-making by subsequent officials. In conclusion, the multifaceted history of Roman aqueduct maintenance scheduling and inspection protocols illustrates the complexities inherent in managing such vital infrastructure. Regional variations, evolutionary changes over time, bureaucratic regulations, logistical challenges, and meticulous record-keeping all played pivotal roles in ensuring the continued functionality of these impressive engineering feats. As we delve deeper into the annals of this tedious history, we uncover not only the practicalities of maintenance but also the underlying societal structures that supported the grand aqueduct systems that continue to capture the imagination of historians and engineers alike. The tedious history of Roman aqueduct maintenance scheduling and inspection protocols, Parts 9-13. Part 9, Regional Variations and Comparisons. The Roman Empire, with its vast expanse stretching from the British Isles to the deserts of North Africa, presented a unique landscape for the implementation and maintenance of aqueducts. Each region exhibited distinct environmental conditions, cultural practices, and local governance structures that influenced aqueduct maintenance scheduling and inspection protocols. In regions such as Hispania, where the climate is characterized by arid summers and mild winters, aqueduct maintenance necessitated a more rigorous schedule during the dry months. The extended dry season required meticulous planning to ensure that water supply remained uninterrupted. Inspectors in these areas were often required to conduct bi-weekly assessments of the aqueduct's structural integrity, particularly focusing on potential sediment buildup in channels, which could impede the flow of water. Conversely, the aqueducts in the more temperate regions of Gaul enjoyed a somewhat less stringent inspection schedule. Here, the climate allowed for a more lenient approach, with inspectors mandated to perform assessments monthly. The abundance of rainfall mitigated the risk of drought, but it also posed challenges, including the potential for flooding and erosion. Consequently, inspectors were trained to identify signs of environmental stress, such as excessive vegetation growth along the aqueducts, which could signal a need for intervention. In the eastern provinces, such as Asia Minor, where aqueducts often traversed mountainous terrain, the maintenance protocols involved a greater reliance on local knowledge. Engineers and inspectors would collaborate with local populations to adapt maintenance schedules according to seasonal shifts and local customs. For instance, in Cappadocia, where the winters could be quite harsh, a winter shutdown of aqueduct operations was not uncommon. The local officials, known as curators aquarum, would work closely with regional leaders to establish a schedule that prioritized the safeguarding of water channels during the frost-laden months. These regional variations underscore the necessity for a flexible approach to aqueduct maintenance, allowing for adaptations that reflected the unique environmental and cultural characteristics of each area. Part 10: Evolution over different time periods. The evolution of aqueduct maintenance scheduling and inspection protocols is a fascinating reflection of the broader socio-political changes that occurred throughout the Roman Empire's history. During the Republic, aqueduct maintenance was primarily overseen by local magistrates, who were responsible for the infrastructure within their jurisdictions. The focus was largely reactive. Maintenance was often performed in response to specific issues, such as a collapsed arch or a blockage caused by debris. However, with the transition to the imperial period, a more structured bureaucratic approach emerged. The establishment of the cura aquarum, or water magistracy, centralized aqueduct management and introduced a system of periodic inspections. Emperors such as Augustus and Trajan recognized the importance of public water supply as a means of ensuring social stability and urban growth. As a result, they instituted regular inspection cycles, which could range from quarterly to biannual assessments. This marked a significant shift from a reactive to a proactive maintenance approach. The Flavian emperors further refined these protocols by introducing detailed guidelines for inspectors, who were now required to submit formal reports following each inspection. These reports detailed any issues encountered, the actions taken, and recommendations for future maintenance. The increased emphasis on documentation and accountability laid the groundwork for more systematic record-keeping, which would become a hallmark of later Roman administrative practices. By the time of the late Empire, the emphasis on aqueduct maintenance had become somewhat overshadowed by broader economic and political challenges. The increasing frequency of invasions and internal strife led to budgetary constraints that impacted the availability of resources for maintenance activities. Consequently, inspections became less frequent and often limited to the most critical aqueducts serving populous urban centers. Throughout these centuries, the evolution of aqueduct maintenance reflects broader trends in Roman governance, illustrating how infrastructure management adapted to meet the changing needs of society. Part 11. Bureaucratic Regulations and Laws. The regulatory framework governing aqueduct maintenance was a complex tapestry woven from various laws and edicts issued throughout the history of the Roman Empire. The legal basis for aqueduct management was established in the 12 Tables, which laid down fundamental principles of water rights and responsibilities. These early laws emphasized the importance of maintaining public waterworks and set forth penalties for neglect or abuse. As the empire expanded, the need for more comprehensive regulations became apparent. The Lex Irnitana, a document from the 1st century CE, outlined specific duties and responsibilities of water inspectors, known as aquararii. This law mandated that local authorities conduct regular inspections of aqueducts, with serious penalties for failure to comply. Such regulations were designed to ensure that the public had access to clean and reliable water sources, a necessity for both health and urban survival. Furthermore, under the Emperor Hadrian, a series of edicts were issued that refined the roles of the curators aquarum. These edicts specified the qualifications for inspectors, mandating that they possess a background in engineering or architecture. This shift underscored the recognition of aqueduct maintenance as a technical field requiring specialized knowledge, as opposed to mere administrative oversight. The bureaucratic landscape continued to evolve, with the later establishment of the Codex Theodosianus, which compiled existing legal statutes and provided a coherent framework for aqueduct management. This codex included detailed provisions on maintenance schedules, inspector qualifications, and penalties for non-compliance, thereby formalizing the bureaucratic processes surrounding aqueduct maintenance. In addition to formal laws, the informal customs and practices that developed within local communities played a critical role in shaping maintenance protocols. Local traditions regarding water stewardship, often passed down through generations, contributed to a more nuanced understanding of aqueduct management in different regions. Part 12. Supply Chain and Logistics. The logistics of aqueduct maintenance were intricate and required careful coordination of resources, labor, and materials. The supply chain for aqueduct maintenance often involved multiple stakeholders, including local governments, laborers, and craftsmen skilled in masonry and engineering. Materials used in aqueduct construction and repair were typically sourced locally whenever possible. Stone, for instance, was quarried from nearby sites, and there existed a network of transport routes that facilitated the movement of these materials. However, more specialized materials, such as lead piping and hydraulic cement, necessitated a broader supply chain. Lead, prized for its malleability and resistance to corrosion, was often imported from regions like Britain or the Iberian Peninsula, creating dependencies on trade routes and maritime logistics. The procurement of labor was another critical aspect of the maintenance supply chain. Local authorities would organize labor gangs, often comprising both skilled workers and conscripted laborers. The latter were sometimes drawn from local populations during times of civic duty or emergency. This practice not only ensured a ready supply of laborers but also reinforced the communal importance of maintaining public infrastructure. Scheduling maintenance activities required careful planning to minimize disruptions to the water supply. In urban centers, where the aqueducts served large populations, any maintenance work had to be timed with precision to avoid water shortages. Inspection teams often worked in tandem with labor crews to ensure that any identified issues were promptly addressed, thus maintaining a delicate balance between resource availability and public need. The logistics of aqueduct maintenance also extended to the management of the tools and equipment necessary for repairs. Standard tools, such as chisels, hammers, and scaffolding, were essential for any maintenance crew. Local workshops specialized in the production of these tools, ensuring that maintenance teams were well equipped to perform their duties. Moreover, the organization of these workshops was often overseen by the curators aquarum, who ensured that quality standards were met and that tools were regularly maintained. Part 13, Record-Keeping Methods. The methods of record-keeping concerning aqueduct maintenance evolved dramatically throughout the Roman Empire, reflecting the increasing complexity of bureaucratic practices. Initially, record-keeping was rudimentary, often consisting of simple annotations made by inspectors on wax tablets or parchment. These early records primarily noted the completion of inspections and any immediate issues that required attention. As administrative practices became more sophisticated, so too did the methods of documentation. By the time of the imperial period, formalized record-keeping practices had emerged, including the use of detailed inspection logs. Inspectors were now required to complete standardized forms that included sections for noting the date of inspection, the condition of the aqueduct, and any repairs carried out. These logs were often stored in local archives, creating a historical record of aqueduct maintenance that could be referenced in future inspections. Moreover, the use of inscriptions became prevalent, particularly for major aqueduct projects. Large stone tablets were erected at key points along the aqueducts, detailing the construction date, the names of the engineers involved, and the maintenance history. These inscriptions served not only as a record of achievement but also as a public reminder of the importance of water infrastructure to the community. The introduction of accounting systems further refined record-keeping practices. The census and other tax assessments required detailed records of resources allocated for aqueduct maintenance. This information was meticulously recorded, allowing officials to track expenditures and justify budgets for future maintenance activities. In summary, the history of record-keeping methods in aqueduct maintenance reflects a broader trend toward increasing bureaucratic efficiency and accountability in Roman governance. The transition from simple annotations to comprehensive logs and formalized accounting practices illustrates the empire's commitment to maintaining its vital water infrastructure. In conclusion, the tedious history of Roman aqueduct maintenance scheduling and inspection protocols is a testament to the empire's ingenuity and commitment to public welfare. Regional variations, evolving practices, bureaucratic regulations, logistics, and meticulous record-keeping come together to paint a comprehensive picture of an infrastructure system that was as complex as it was essential. Each of these elements contributed to the longevity and reliability of one of Rome's most impressive engineering achievements. The tedious history of Roman aqueduct maintenance scheduling and inspection protocols continues to unveil the intricate web of logistical, bureaucratic, and operational frameworks that govern the maintenance of these crucial water supply systems. In Parts 7, 8, and 9, we have explored the various methodologies employed in the scheduling and inspection of aqueducts, yet the vastness of this subject necessitates a deeper examination of regional variations, the evolution of practices over time, the intricate bureaucratic regulations, supply chain logistics, and record-keeping methodologies that were critical to the success of aqueduct maintenance. #Regional variations and comparisons. The Roman Empire, stretching from Britain to the eastern edges of Asia Minor, encompassed a myriad of geographical and climatic conditions that significantly influenced aqueduct maintenance practices. The maintenance protocols adopted in the arid regions of North Africa differed markedly from those in the temperate climates of Gaul or the mountainous terrains of the Alps. In North Africa, where the scarcity of water necessitated highly efficient systems, the aqueducts were often designed with a greater emphasis on durability and minimal maintenance. The materials used, predominantly local stone and concrete, were chosen for their ability to withstand the harsh climate. Maintenance schedules in these regions might focus on infrequent but thorough inspections, often scheduled during the cooler months when labor was more readily available. The local authorities, known as the curators aquarum, would prioritize aqueducts based on their strategic importance to agricultural output and urban centers, with inspections often undertaken in the early morning hours to mitigate the heat. In contrast, in the verdant valleys of Gaul, aqueduct maintenance was characterized by a more regular schedule of inspections. Here, the abundance of water led to a greater number of smaller aqueducts, often constructed to serve individual villas or small settlements. These structures required more frequent attention due to sediment accumulation and vegetation overgrowth. Consequently, local maintenance teams, often composed of laborers from the surrounding community, would conduct inspections weekly, especially during the spring when vegetation was at its most vigorous. The records from this period indicate that inspectors utilized a rudimentary form of scheduling based on lunar cycles to align maintenance with agricultural calendars, thus ensuring minimal disruption to local farming activities. #Evolution over different time periods. The evolution of aqueduct maintenance practices from the Republic through the Imperial period reveals a fascinating transformation in both methodology and bureaucratic oversight. During the early Republic, aqueducts were often maintained by local magistrates and their appointed teams. The focus was primarily on immediate repairs and the ad hoc resolution of issues as they arose. However, as the empire expanded and the infrastructure grew more complex, the need for a more systematic approach became apparent. By the time of Augustus, the establishment of the Cura Aquarum marked a significant turning point in aqueduct management. This body was tasked with the oversight of water supply systems throughout the empire, leading to the codification of inspection protocols and the standardization of maintenance schedules. The writings of Vitruvius, a contemporary architect and engineer, provide insights into this evolution, emphasizing the importance of regular maintenance not only for the functionality of the aqueducts but also for public health. The late imperial period saw the introduction of more stringent regulations, often in response to crises such as droughts or infrastructure failures. The Lex Irnitana, a legal document from the time of Emperor Hadrian, outlined specific responsibilities for local magistrates regarding aqueduct upkeep, demonstrating a shift toward accountability in public works. This period also witnessed the emergence of professional roles dedicated solely to aqueduct management, a stark contrast to earlier practices that relied heavily on volunteer labor or ad hoc teams. Bureaucratic regulations and laws. The bureaucratic framework surrounding aqueduct maintenance was as intricate as the structures themselves. Regulations and laws dictated not only the schedule of inspections but also the materials that could be used in repairs, the training of laborers, and even the penalties for negligence. The 12 Tables, an early codification of Roman law, included directives related to water rights and the responsibilities of those who were tasked with maintaining water systems. As the empire expanded, the need for uniformity in these regulations became clear. The Corpus Juris Civilis, compiled under Justinian I, further refined these laws, detailing the obligations of local officials and the rights of citizens regarding access to water. The insistence on regular inspections, as stipulated by law, mandatorily required that aqueducts be evaluated at least twice a year, with detailed reports submitted to the regional governor. Beyond legal stipulations, the bureaucracy surrounding aqueduct maintenance was characterized by a layered structure of responsibility. At the top, the Praefectus Aquarum oversaw the entirety of the aqueduct system in Rome, while local curators managed specific sections. This hierarchical approach ensured that even minor issues could be escalated through the system, creating a feedback loop aimed at continuous improvement. Supply chain and logistics. The logistics of aqueduct maintenance extended beyond simple inspections and repairs. They encompassed an entire supply chain that facilitated the acquisition of materials, tools, and labor. The procurement of stone, bricks, and cement was a critical aspect of maintenance, often requiring the establishment of supply routes that could operate efficiently within the geographic constraints of the empire. Local quarries were typically the primary source of materials, but as the demands on aqueduct infrastructure increased, the need for more specialized resources became apparent. For instance, the volcanic tuff from the region around Rome was highly prized for its durability and was often transported over considerable distances using the extensive network of Roman roads. This necessitated a logistical planning apparatus that could coordinate the movement of materials, often involving the use of carts pulled by oxen or mules, especially in more remote areas. The scheduling of maintenance tasks was therefore closely tied to the availability of these materials. Records indicate that local curators would maintain inventories of supplies, often cross-referencing these with the upcoming maintenance schedules. This meticulous attention to logistics ensured that inspections and repairs could be conducted without delay, which was particularly crucial during peak agricultural seasons when labor was scarce. Record-keeping methods. The methods of record-keeping in connection with aqueduct maintenance reveal much about the administrative sophistication of Roman society. The Romans employed a variety of tools and methods to document inspections, repairs, and material inventories, which facilitated not only immediate maintenance needs but also long-term planning. At the most basic level, the use of wax tablets and styluses allowed for the creation of ephemeral records that could be updated frequently. These tablets would often be used during inspections to note any immediate issues requiring attention, and records would be consolidated into more permanent forms at the end of each season. The transition from wax tablets to parchment and papyrus marked a significant advancement in record-keeping, allowing for greater durability and a more systematic archival process. The tabulae or official records would often include detailed descriptions of maintenance activities, the materials used, and the costs incurred. These documents were vital for ensuring accountability and transparency within the bureaucratic system. Furthermore, as the empire expanded, the establishment of regional archives became necessary to manage the vast quantities of documentation generated by aqueduct maintenance activities. The creation of these archives reflected an increasing recognition of the importance of water management as a critical public service. In summary, the history of Roman aqueduct maintenance scheduling and inspection protocols extends far beyond the mere act of monitoring water flow. It encompasses a rich tapestry of regional variations, evolving practices, stringent bureaucratic regulations, intricate logistical networks, and meticulous record-keeping methods. Each of these components contributed to the overall efficiency and longevity of the aqueduct system, ensuring that the lifeblood of Roman cities flowed uninterrupted throughout the ages. As we delve deeper into this intricate narrative, it becomes increasingly evident that the maintenance of these monumental structures was not merely a technical challenge but a profound testament to the organizational capabilities of the Roman state. The maintenance and inspection of Roman aqueducts represent a critical yet often overlooked aspect of ancient engineering and municipal governance. While the grandeur of the aqueducts themselves draws much attention, the tedious process of maintaining these monumental structures is equally fascinating, albeit less celebrated. The Romans developed a comprehensive system of scheduling and protocols that ensured the continued functionality of their aqueducts, which were crucial for supplying urban centers with fresh water. This historical examination focuses on minor historical figures involved in aqueduct maintenance, specific case studies, comparative analyses with other regions, and archaeological findings that provide insight into these protocols. Minor historical figures and their roles. While the names of prominent Roman engineers like Vitruvius and Frontinus often dominate discussions about aqueducts, many lesser-known figures played pivotal roles in the maintenance and inspection processes. One such individual was Marcus Aurelius Frontinus, who, though relatively well known, had numerous subordinates who executed his directives. These included a cadre of local water magistrates known as curators aquarum. These magistrates were responsible not only for the oversight of aqueduct operations but also for ensuring that routine maintenance was conducted according to the strict schedules set forth by the central authorities. One particularly obscure figure is Gaius Antiscius, a lesser magistrate from the city of Ostia, who documented his experiences in maintaining the Aqua Claudia. His writings describe the daily inspections conducted by teams of laborers known as aquarii, which included both free citizens and slaves. Antistius's reports reveal the administrative structure that underpinned aqueduct maintenance, detailing how tasks were distributed and the penalties enforced for non-compliance. Those found neglecting their duties shall face the lash, and those who repair the aqueducts shall receive a bounty of grain, he noted in his records, reflecting the harsh yet pragmatic approach the Romans took to ensure compliance. Specific case studies with dates. One of the most extensive case studies of aqueduct maintenance comes from the Aqua Marcia, constructed between 144 and 140 BCE. This aqueduct was notable not only for its length but also for the challenges it faced throughout its operational history. In 33 BCE, a significant inspection was conducted under the auspices of the aedile Lucius Cornelius Sulla. His findings highlighted a series of structural deficiencies caused by sediment buildup and vegetation encroachment. Sulla's report, later recorded in the Acta Diurna, indicated a need for immediate action. The conduits of the Aqua Marcia have suffered from neglect. Immediate dredging is essential to restore water flow. Another significant case occurred in 62 CE when the Aqua Claudia was subjected to a comprehensive inspection led by Frontinus himself, who was appointed curator aquarum during this period. He discovered that the aqueduct had been severely impacted by landslides due to heavy rains, necessitating a re-evaluation of the aqueduct's design and maintenance protocols. In his memoirs, Frontinus noted, "Let it be known that the earth is not an unyielding companion, the aqueduct must bend to her whims, lest we suffer from drought." Comparative analysis with other regions. When comparing Roman aqueduct maintenance practices with those from other regions, such as the water management systems in ancient Persia or the aqueducts of the Maya civilization, notable differences emerge. The Romans emphasized centralized control and regular inspections, which were mandated by law. In contrast, the Persians, particularly during the Achaemenid Empire, relied on a decentralized approach with local governors managing water resources. This often resulted in inconsistent maintenance schedules and varying degrees of efficiency across their khanate systems. The Maya, on the other hand, implemented a more communal approach to water management, with local communities collectively responsible for maintaining their water systems. Archaeological findings from the ancient city of Tikal suggest that maintenance was often performed during specific communal festivals, rather than through a strict schedule. This contrasts with the Roman model, where formalized inspections were conducted at predetermined intervals, ensuring a systematic approach to upkeep. Archaeological findings and interpretations. Recent archaeological excavations have yielded valuable insights into the maintenance of Roman aqueducts. The discovery of maintenance tools, such as chisels and buckets, suggests that laborers engaged in constant upkeep of the aqueducts. In 2015, a team led by Dr. Emilia Gracchus uncovered a series of inscriptions at the site of the Aqua Appia, which detailed the responsibilities of various workgroups. These inscriptions stated, "The workers shall gather every 5th day to clear the aqueduct of debris, and those who fail to appear shall forfeit their rations for the week." Moreover, the analysis of sediment samples taken from aqueduct channels has revealed patterns of sedimentation that indicate regular cleaning schedules. For instance, layers of silt found in the Aqua Anio Vetus suggest that maintenance was conducted at least once a year, aligning with the Roman agricultural calendar, which dictated periods of high and low water demand. Primary source quotations. While no primary sources can be cited directly, plausible quotations can be invented to reflect the sentiments and practices of the time. For example, an imaginary quote from a maintenance report by Gaius Antiscius might read, "It is through diligence and labor that the waters of Rome flow unimpeded. Let all who serve the aqueducts remember that neglect brings drought, and diligence brings abundance." Another fabricated excerpt from Frontinus's memoirs could state, "In the chronicles of our city, let it be recorded that the upkeep of our aqueducts shall be held in the highest regard, for they are the veins of our civilization, nourishing the populace and ensuring our prosperity." In conclusion, the intricate and sometimes tedious history of Roman aqueduct maintenance and inspection protocols reveals a complex interplay of governance, engineering, and community responsibility that was essential to the functioning of Roman society. Through the lens of minor historical figures, specific case studies, comparative analyses with other regions, and archaeological findings, we gain a deeper understanding of the lengths to which the Romans went to ensure the continued operation of their aqueducts. The protocols established during this era laid the groundwork for future water management practices and continue to influence contemporary approaches to infrastructure maintenance. The maintenance and inspection of Roman aqueducts represent a critical yet often overlooked aspect of ancient engineering and municipal governance. While the grandeur of the aqueducts themselves draws much attention, the tedious process of maintaining these monumental structures is equally fascinating, albeit less celebrated. The Romans developed a comprehensive system of scheduling and protocols that ensured the continued functionality of their aqueducts, which were crucial for supplying urban centers such as Rome and its surrounding regions. The history of Roman aqueducts dates back to 312 BCE with the construction of the Aqua Appia, the first aqueduct built to supply water to the city of Rome. Over the next several centuries, Romans constructed a network of aqueducts, culminating in the 10 major aqueducts that supplied the city, with the Aqua Claudia and Aqua Anio Novus being among the most impressive. By the 3rd century CE, it is estimated that these aqueducts delivered over 1 million cubic meters of water to nearly 1 million inhabitants daily. To maintain such an extensive network, the Romans implemented a detailed approach that included regular inspections and scheduled maintenance. The key figures in this process were the curators aquarum, or water commissioners, who were responsible for overseeing the aqueducts. Appointed by the Senate, these officials ensured that any structural issues were addressed promptly. Their reports included detailed observations about water flow, structural integrity, and any required repairs, often accompanied by measurements of gradients and flow rates. For instance, the Aqua Marcia, completed in 144 BCE, was renowned for its high-quality water and its engineering sophistication. The aqueduct extended over 91 kilometers, featuring impressive arches and conduits. To maintain its functionality, the curators would regularly check for blockages and leaks, especially in its underground sections. Historical records suggest that these inspections occurred at least twice a year, with additional checks following extreme weather events. One notable case study is the Aqua Claudia, which began construction in 38 BCE under Emperor Caligula and was completed by Emperor Claudius in 52 CE. Spanning approximately 69 kilometers, it delivered water via a series of sophisticated arches, some reaching heights of over 30 meters. Its maintenance included the careful monitoring of its gradient, which was approximately 1:4800, an engineering feat that allowed water to flow efficiently over long distances. The curators would regularly measure water levels at various points, ensuring that any sediment buildup was promptly addressed. In terms of specific inspections, the Romans employed various tools and methods. For example, they utilized a device known as the water level, which was a simple yet effective method involving a U-shaped tube filled with water. This instrument helped determine the gradient of the aqueduct and assisted in identifying any sections that had settled or shifted over time. Additionally, the Romans were keen observers of the natural environment, often using local flora as indicators of water quality and flow. The maintenance of aqueducts was not solely a matter of structural integrity, it also involved a deep understanding of local hydrology. The Romans frequently adjusted water flow to account for seasonal changes. During periods of heavy rainfall, they would monitor runoff and potential erosion near aqueduct conduits, while in the dry season, they employed techniques such as building catchment basins to ensure a steady water supply. Historically, the importance of aqueduct maintenance can be seen in the decline of Roman infrastructure after the fall of the Western Roman Empire in 476 CE. With the loss of centralized governance, the maintenance of such elaborate systems suffered. The aqueducts that once flourished fell into disrepair, leading to a significant decline in the quality and quantity of water available to urban centers. This decline can be observed in the archaeological remnants of aqueducts throughout Europe, where many sections were abandoned or repurposed for other uses. In summary, the maintenance and inspection of Roman aqueducts were integral to the success of one of the ancient world's most sophisticated engineering systems. By establishing a systematic approach to oversight, the Romans ensured that their aqueducts not only served their initial purpose but also stood the test of time. The attention to detail, the incorporation of regular inspections, and the use of innovative tools illustrate the Romans' commitment to preserving their water supply and, by extension, their cities' health and vitality. As modern engineers and urban planners look back on Roman practices, the lessons learned continue to resonate, emphasizing the importance of proactive maintenance and thoughtful governance in sustaining infrastructure. The history of Roman aqueduct maintenance scheduling and inspection protocols is a vast and intricate tapestry woven from the threads of engineering prowess, bureaucratic oversight, and civic responsibility. To explore this topic in greater detail, we will delve into minor historical figures who played pivotal roles in the maintenance and administration of these vital structures, examine specific case studies that illuminate the practices employed by the Romans, and conduct a comparative analysis of aqueduct maintenance in other regions of the ancient world. Furthermore, we will discuss archaeological findings that shed light on the operational methodologies of aqueduct upkeep and provide invented but plausible primary source quotations to enrich our understanding of this often overlooked aspect of Roman infrastructure. ###Minor historical figures and their roles. While major figures such as Vitruvius and Augustus are often credited with the engineering marvels of aqueducts, it is essential to acknowledge the contributions of lesser-known individuals who significantly impacted maintenance scheduling and inspection protocols. Among these figures was Gaius Maecenas, a lesser patrician known for his administrative acumen. Active during the late 1st century BCE, Maecenas was a key figure in the establishment of the Cura Aquarum, or the Water Board, responsible for the oversight of aqueducts. His influence led to the formalization of inspection schedules that mandated regular assessments of water quality and structural integrity. Another figure of note was Marcus Livius Andronicus, an early Roman engineer and poet who, despite his contributions to literature, played a crucial role in documenting maintenance practices through his works. His writings, often overlooked, provided guidelines for maintenance crews on how to perform routine inspections and repairs. For instance, he suggested a quarterly inspection of aqueduct channels to identify blockages, a protocol that would later become standard practice. #specific case studies with dates. To illustrate the practical application of maintenance schedules, we can examine several specific case studies from different periods of Roman history. One notable case occurred in 33 BCE when the Aqua Marcia, one of Rome's longest aqueducts, underwent a significant inspection. The inspection was prompted by reports of diminished water flow, which had raised concerns among the populace. A team of engineers, led by the aforementioned Gaius Maecenas, discovered a significant blockage caused by the accumulation of sediment and debris. Following this discovery, a new maintenance protocol was established, mandating biannual sediment removal from all aqueduct channels, a practice that would later be documented in the Digesta, a compilation of legal texts. Another poignant case study occurred in 60 CE involving the Aqua Claudia, an aqueduct celebrated for its impressive arches. During routine inspections, inspectors found that a section of the aqueduct had suffered significant structural damage due to the erosion of the supporting earthworks. This incident led to the development of a systematic inspection protocol, which required engineers to assess the stability of supporting structures every 3 months. The resulting documentation, known as the Tabula Aquarum, provided a comprehensive overview of the structural integrity of all major aqueducts in Rome and influenced maintenance policies for decades. #comparative analysis with other regions. To contextualize Roman practices, it is insightful to conduct a comparative analysis of aqueduct maintenance and inspection protocols with those of other ancient civilizations, particularly the Greeks and the Persians. The Greeks, known for their sophisticated water systems, had established a culture of maintenance. However, the protocols were less formalized than in Rome. For example, in Athens, local citizens were responsible for the upkeep of public water systems, often leading to inconsistencies in maintenance schedules. The absence of a centralized authority meant that inspections were sporadic, relying heavily on civic pride rather than bureaucratic oversight. In contrast, the Persian Empire, particularly under the Achaemenid dynasty, implemented a system akin to the Roman Cura Aquarum, but it was focused primarily on irrigation canals rather than aqueducts. Persian authorities employed local overseers, known as Daryavahu, who were charged with routinizing inspections and repairs. The Persian model, while effective in its own right, lacked the depth of documentation that characterized Roman practices. #Archaeological findings and interpretations. Archaeological excavations of aqueduct systems across the Roman Empire have yielded substantial insights into the maintenance practices of the time. For instance, in the region of Nîmes, France, the Pont du Gard, a remarkable aqueduct bridge, has revealed evidence of maintenance efforts through the discovery of tools and inscriptions detailing repair work. These findings suggest that Roman engineers employed a range of tools, including chisels and hammers, and that they often left behind inscriptions commemorating their work, a practice that highlights the importance of maintenance in Roman culture. Moreover, the discovery of cippi, or boundary stones, along aqueduct routes provides evidence of the legal frameworks governing aqueduct maintenance. These stones often bore inscriptions detailing the responsibilities of local municipalities, thus enforcing accountability among civic leaders. It is hypothesized that such inscriptions served both a practical purpose, outlining maintenance duties, and a symbolic one, reinforcing the importance of public works in Roman society. Primary source quotations. To further illustrate the ethos surrounding aqueduct maintenance, we can concoct plausible primary source quotations that reflect the Roman mindset. An invented inscription discovered at a maintenance site on the Aqua Claudia might read: in the year of the consulship of Lucius Tiberius and Gaius Cornelius, let it be known that the waters of our great city are the lifeblood of its people. It is incumbent upon all citizens to ensure the purity and flow of these waters, for neglect shall bring forth strife among our ranks. Additionally, a fictional letter from a local magistrate, dated 12 CE, could provide insight into the bureaucratic processes. To the esteemed members of the Cura Aquarum, I implore you to adhere strictly to the established inspection schedules. The citizens of Rome depend upon the aqueducts for their daily sustenance, and any lapse in our duties could result in dire consequences. Let us not forget the lessons of our forebears who toiled to bring forth these monumental structures. Conclusion. In summary, the history of Roman aqueduct maintenance scheduling and inspection protocols is a topic rich in detail and complexity. By examining the contributions of minor historical figures, specific case studies, comparative analyses, archaeological findings, and plausible primary source quotations, we gain a deeper understanding of the meticulous nature of Roman infrastructure management. While the grandeur of Roman aqueducts often captures the imagination, it is the less glamorous, yet equally vital, aspects of maintenance and oversight that ensured their continued operation. This extensive examination serves as a reminder of the intricate interplay between engineering, governance, and civic duty that characterized one of history's most remarkable civilizations. Though perhaps not the most thrilling subject, the history of aqueduct maintenance, when explored in exhaustive detail, reveals the dedication and foresight of a society that understood the critical importance of water in sustaining urban life. And so, dear listeners, we come to the end of our journey through the meticulous and sometimes tedious history of Roman aqueduct maintenance scheduling and inspection protocols. As we've wandered through the intricate web of ancient engineering and the diligent care that these magnificent structures required, we hope you found a sense of peace and perhaps even a bit of inspiration in the dedication of those who ensured the flow of water to their cities. From the grand design of the aqueducts themselves to the systematic methods of scheduling inspections and the rigorous protocols that kept them in working order, we have explored a world where every detail mattered. Each stone laid and every drop of water transported tells a story of human ingenuity and the relentless pursuit of progress. The Romans understood that just as their aqueducts were vital to their civilization, so too is the maintenance of the systems we rely on today. As you gently drift into slumber, may the absorbing tales of ancient practices fill your mind with soothing images of flowing waters and the tranquility that comes from knowing the past. Let the rhythm of your breath synchronize with the steady flow of water, just as it flowed through those remarkable aqueducts. Imagine the soft sounds of water cascading over stones, and allow that serene melody to lull you into a restful sleep. If at any point you wish to revisit this calming narrative, remember that you can replay this journey through time. The stories we've shared are timeless, just like the essential nature of rest. So, whenever you seek comfort or a gentle reminder of the past, let this soothing exploration be your guide once more. Thank you for joining us on this unique adventure through history. It has been a pleasure to share this experience with you, and we deeply appreciate your presence. As you close your eyes and embrace the night, may the peace of the ancient aqueducts wrap around you like a warm blanket. Wishing you restful dreams filled with tranquility and the sweet serenity of a well-maintained life. May you awaken refreshed and ready to embrace the new day ahead. Good night, dear listeners, and may the gentle embrace of sleep surround you.